The focus of their attention was the patina, the weathered layer on the outside of the stone. It was this, especially the charcoal particles that were dated to 2,300 years ago, that had convinced the scientists who had carried out the original analysis. Elisabetta Barreto was asked to redate those particles.
The radiocarbon age was 2,250 plus minus 40 years. This is a very nice, precise age. And calibrated, this corresponds to an interval in time that goes from the 200 BC, before Christ, to the 390 BC.
Her results seemed to confirm the original research. The charcoal in the patina was very old. But it was, theoretically, possible for someone to have taken charcoal from another source and added it to the patina. For Dr. Barreto, the only way to be absolutely sure of the stone was to look again at the patina in which the charcoal was embedded. The man charged with this task was one of Israel's top archaeological investigators. Yuval Goren is a professor of archaeology at Tel Aviv University and a geologist. He has a detailed knowledge of both biblical archaeology and the rocks of the Jerusalem area. He began by looking at the patina on the back of the stone. An authentic patina would be firmly attached to the underlying stone.
This patina on the back of the stone is actually it was very tightly connected to the stone. We needed a little chisel and a hammer to peel off small samples of the patina.
This was clearly a natural patina. But then Professor Goren examined it under the microscope. He expected it to be made of calcium carbonate, which is local to the Temple Mount. But what he saw was this: a patina made only of silica. This could not have formed in Jerusalem. In other words, the patina on the back of the stone could not have come from the Temple Mount. Puzzled, Professor Goren turned his attention to the patina covering the inscription on the front of the stone. Here he did find calcium carbonate, just as one would expect of a patina formed in Jerusalem. But now there was a new mystery. How could the patina on the front of the stone be different from that on the back? The answer began to emerge as Professor Goren sampled the patina from within the carved letters. Strangely, it didn't seem to be bonded to the stone in any natural way at all.
Patina is very loosely connected to the stone. Here you can see how it reacts to me scraping it with a matchstick, and you can see that it easily peels off the letters as opposed again to the patina on the backside.
And when he studied the patina on the front of the stone in detail, he found something else even stranger. Tiny marine fossils called forams.
Within the patina they are quite common. Here we can see one, and here we can see other two.
These fossils could only be found if the patina formed beneath the sea, and the Temple of Solomon was nowhere near the sea.
Of course, one can't expect to find such fossils of plankton, of marine organisms, in a patina that is created in land environment.
This was a complete mystery. It seemed impossible for a patina from a temple built in Jerusalem to contain the fossils of sea creatures. Then came the most telling detail of all.
When the letters are cleared, the inner part of the letters is exposed, and as you can see here, it is very freshly cut. You can see even the little lines, the little parallel lines of either the chisel or even maybe some drill, some electric bit or drill with which the letters were engraved, which is of course very unusual for ancient inscriptions.
So he put it all together. The inscription had been recently carved. There were two different patinas, and the one on the front contained marine fossils, impossible if it had formed in Jerusalem. He concluded the patina on the front of the stone was artificial, a mixture to which gold and Iron Age charcoal had been added by hand.
And therefore I believe that the stone, or not the stone of course, but the inscription is not genuine.
Alarmed by what he'd found with the stone, Professor Goren turned his attention to the James ossuary. Again, he found a similar story. A freshly cut inscription with an artificial patina applied over the top. On the 18th of June 2003, the Israeli authorities delivered their conclusion.
Good day to all of you, to all of us. The patina in the letters in both items is a model forgery covering the letters. The conclusion is that the two inscriptions are modern inscriptions. This is a forgery, totally, without any doubt about it.
The two most important biblical finds in a generation were proven to be fakes. There was no archaeological proof for the existence of Jesus Christ. There was no evidence for the existence of the Temple of Solomon. There was now outrage in the world of Israeli archaeology. How had the forgers succeeded in fooling some of the country's top scholars? How had they managed to pull it off? Yuval Goren, whose work had helped expose the forgery, was determined to find the answers.
Forgeries are a contamination of science, of archaeology as a science. Science is being biased, history is being biased, archaeology is being biased, and as the more sources like that appear, forged, fake sources like that appear, of course science is more distorted.
He began his investigations with the black stone itself. His analysis showed the stone was of a rock type that was not indigenous to Israel. He knew that for the inscription, the forgers had needed an old black rock already cut to a rectangular shape. and he thought he'd worked out how they had acquired it. Just up the coast from Tel Aviv is an old Crusader fortress. The stones in its walls have already been cut to shape. Some of them are black, and many are not local. The Crusaders brought them here.
Ships that used to come to this place were loaded sometimes with ballast stones to hold them balanced, and then they used to unload them, and so these stones were in many cases reused for building. This stone is a dark stone. It's obviously not a local stone to this area, which is already carved. It was probably carved to its rectangular shape in order to place it as the dressing of this wall. And so somebody coming to such a place could find dark stones like that are already made up to a rectangular flat shape.
Professor Goren was now certain. The stone used for the inscription must have come from this or a similar Crusader fort. But for the forgers, getting hold of an old stone of the right shape was just the first step in making an inscribed tablet capable of fooling the experts. The team of forgers must have included a scholar of ancient Hebrew to write the elegant inscription. Then they would have needed a master stone carver who could inscribe it. But above all else, the thing they had to get right was the patina. Just how had it been possible to concoct a mixture that had convinced Israel's top geologists that it was an ancient patina from Jerusalem's Temple Mount? To solve this puzzle, the investigating authorities brought in geochemist Avner Ayalon. He dissolved samples of the patina in acid to produce a gas containing different types of oxygen atoms called isotopes. Each isotope has its own unique atomic weight, and the quantity of each isotope in the gas can be determined using a mass spectrometer. Measuring the ratio of these different isotopes tells Dr. Ayalon the temperature at which a patina has formed. His results were revealing. The patina on both the inscription and the ossuary had formed at temperatures far too hot for them to have occurred naturally.
The temperature which I calculated, 40 to 50 centigrade, for sure it is much higher than natural temperatures that prevailed in Jerusalem area in the last 3,000 years.
This high temperature gave Dr. Ayalon a clue as to how the patina had been formed. He believes the ingredients of the patina must have been ground up, with hot water being added to help them dissolve.
Someone grinded calcium carbonate, grind it and mix it in hot water. You use hot water, then you get a much better cementation of the artificial patina, which a bit cemented to the artifacts.
One of the crucial ingredients was chalk. It was this that had provided the calcium carbonate for the patina. It also explained why forams had been found. They are very common fossils in chalk.